Right now, humanity's furthest traveled object is a spacecraft called Voyager 1. It's been flying nonstop at over 38,000 miles per hour for almost 50 years straight. This November, after all that time, it's finally gonna reach a distance called 1 light day. A light year is 365 of those. We've never sent anything even 1 full light year away, not even close. And once you actually see the math, you'll understand why light year might be the most casually thrown around unit in all of science. Let's start with the basic definition. A light year is simply just the distance light travels in 1 year. That requires knowing how fast light moves, which in itself is impossible to picture. Light travels at about 186,000 miles every second. In the time it takes you to blink, light could have already circled the entire Earth more than 7 times. Now stretch that speed out for an entire year non-stop and you get 1 light year. In actual miles, that's about 5.88 trillion miles. That's a number so big, it stops meaning anything once you hear it. So let's make it mean something. Here's a way to actually feel the distance rather than just hearing a number. Imagine you shrink the distance between Earth and the Sun, all 93 million miles of it, down to just 1 inch. Tiny, but the kind of distance you can measure with your fingers. At that same scale, a light year would still stretch out about a mile. Let me say that again to emphasize just how crazy that is. Shrink the entire distance from the Earth to the Sun down to 1 inch, and a light year is still roughly a mile away. The Sun is the closest star to Earth, and a light year is nowhere near the distance to even the next closest star. It's just the unit that we start measuring these kind of distances in. So how close have we actually gotten to traveling a light year? This is where Voyager 1 comes back in. Launched in 1977, Voyager 1 is the most distant human-made object ever built. It's currently flying through interstellar space at roughly 38,000 miles per hour, and it has never stopped moving since the day it launched. After nearly 50 years of that, completely uninterrupted, Voyager 1 is expected to cross the 1 light day mark this November. A light day is the distance light travels in just 24 hours, but that's about 16 billion miles. It's taken our furthest traveling spacecraft basically half a century to cover the distance that light itself covers in a single day. And as you can imagine, a light year is 365 of those light days. Which means if Voyager 1 kept flying at this exact speed, it would take roughly 18,000 years just to cover 1 full light year. 18,000 years to cover the distance light itself covers in 1 year. We've had Voyager flying for less than 50 years. We are nowhere near 1% of the way to 1 light year, with the fastest, longest traveling object humanity has ever made. And here's another crazy thing. A light year barely gets you anywhere when you actually are out in the universe. The nearest star to our sun, a small star called Proxima Centauri, is about 2.4 light years away. At Voyager's pace, reaching it would take more than 75,000 years. And that's the closest star that exists. Every other star that you can see in the night sky is even further than that. One of the most interesting parts of this whole thing to me is the fact that light takes time to travel. So looking at a star like Proxima Centauri, you're actually looking at light that's left over from over 4 years ago. So you're really looking at the star's past. The further you zoom out, things get even stranger. Our entire galaxy, the Milky Way, is roughly 100,000 light years across. Some of the galaxies we can photograph with telescopes are so far away that their light has been traveling towards us for billions of years. When you look at those images, you're not looking at a distant place, you're looking at what the universe looked like billions of years ago, before Earth even existed. A light year isn't just really far. It's a unit built entirely out of how fast the fastest thing in the universe moves, stretched out across an entire year. And humanity's best machine hasn't even covered 1% of it after 50 years of trying.